This is a gate problem that appeared in the year 2022 for the instrumentation engineering paper, and these are based on active filters. Questions of this pattern are very common to ECE as well as electrical engineering branches. The question is stated as: the circuit shown is driven by a sinusoidal input voltage V in, resulting in the output voltage V out. The frequency in kilohertz at which the voltage gain is 0 dB is dash. The answer should be rounded up to 2 decimal digits. So this is the corresponding active filter circuit, and the way to proceed with these sort of questions is, instead of mentioning these values, mention them in their generalized form. So you can mention this resistance as R1, this resistance can be mentioned as R2, and in the Laplacian domain the capacitive reactance is mentioned as 1 by SC. And then we can go one step further, and with this part we find that the resistance and the capacitance are in parallel, and therefore we can write the net impedance to be Z2S equal to R2 parallel of 1 by SC, and this will lead to this expression, which is R2 divided by 1 plus SCR2. Next, if we look at this topology, this is an inverting amplifier's topology, and therefore V out S by V in S can be formulated as negative of Z2S divided by R1. And so if you substitute this expression for Z2 and divide it by R1, it leads to this particular expression. So V out S by V in S is equal to negative of R2 by R1 multiplied by 1 by 1 plus SCR2. The next step in solving for active filter circuit is to substitute S with j omega, where omega is the angular frequency variable expressed in radians per second. Therefore, V out by V in of j omega is equal to negative of R2 by R1 multiplied by 1 by 1 plus j omega CR2. So we are substituting S with j omega over here. The next step after this would be to look for the magnitude term, because we are looking at the voltage gain. So we are looking at the magnitude of this frequency domain expression. So mod of V out by V in of j omega is equal to R2 by R1 multiplied by square root of a square plus b square. This is in the form of a complex number. So this will be 1 square plus omega CR2 whole square. And then proceeding forward, in the question it is mentioned that the voltage gain is 0 dB, and we know that 0 dB corresponds to 1, the numeric value 1. And so if we take a square on both sides of this expression, then we can write 1 is equal to R2 square divided by R1 square multiplied by 1 plus omega square R square R2 square C square. And from here the values of R1, R2 and C are already known to us. They are given in the question. So R1 equals to 10 kilo ohm, R2 is 100 kilo ohms, and C is 1 nanofarad. So substituting those values and doing this simple math, we can come up with the expression for omega, which is equal to 10 to the power 5 radians per second. Now note that the question requires the answer to be stated in kilohertz. The frequency should be mentioned in kilohertz unit. But what we have found over here is in radians per second. So the relation between omega and hertz is given by omega is equal to 2 pi f, where f is the frequency in hertz. And therefore 2 pi f equals to 10 to the power 5, from where the value of f is obtained as 15.91 kilohertz.